And now we can then move on for the next talk. I would like then to invite Mourad FARAJ. Mourad, sorry, I hope I pronounced it correctly, who will talk to us about aerospace technology. Welcome, Faraj. Please join us. You have 20 minutes for your talk. I think Faraj is here, right?
Yes, I'm here.
Okay. Okay, so welcome. Yes, please. The stage is yours.
Thank you. I will just share my screen. Is that the screen as sharing?
I think it's coming. So far, I cannot see anything.
Okay.
Nothing yet.
So they take some minutes. So I can begin. Thank you for the invitation. I'm so glad to be here and to share my experience as a scientist in aerospace technology. So let's begin our journey.
We still don't see your slides.
I think it's...
Oh, yes, no, yeah, finally, yeah, please. Sorry.
Thank you, dear Gustavo. So, like I said, the aerospace technology is one of my field of experience. I work with the CNES, is the National Center of Aerospace Technology in France. So we work in all in satellite and nanosatellite. So this kind of topic, they remember me when I was so shy. I think when I look into the sky, I observe some kind of stars are shine. So a lot of people who ask me, is that a star or a satellite? The most of people have the same question. So for this reason, I try to study aerospace technology in my field of study in as an engineering in rocket. Like we see there, the early satellite developments are in the history are began when we have the two polarization between the Soviet and the US. So the first thing, I think the first satellite will be sent in to the space, it is a Sputnik in 1957, and this satellite, all the American, when we have this information, is that the Soviets sent the first satellite. It's called there is a spy in our sky. So all the people are going out of home and observe the sky. So that mean the importance of this satellite. So because of them, we can call, we can speak right now. We can do a lot of things remotely. Also, this kind of nanosatellite or satellite, they gave us a lot of things. We working in the National Center of Space Study to innovate a lot of satellite. A lot of kind of satellite is a nanosatellite or micro satellite or pico satellite. All of this kind of satellite is doing for research, because the cost of building this satellite is so cheap, and also we can work it with a lot of students to make some prototype and some flight simulation before we can send it. And you know, the cost of to send a satellite is very hard. So when we when we take this satellite in a small size, so we can deeply have a low cost. So there is a lot of think like this kind of satellite or aerospace technology. They give us a lot of things to advancement astronomy, and to discover a lot of things like exoplanet, cosmic microwave background radiation, dark matter. Maybe we can discover a lot of things as how our universe are began. And this satellite application and can give us some good issues, like we can working on communication and navigation, Earth observation, and scientific research. We 2 months ago we sent in two nanosatellite. Is a Moroccan nanosatellite. We do a collaboration with the National Center of Space Study in France, and the University of Mohammed V in Rabat in Morocco, and we work on together to have the first 2 nanosatellites built by Moroccan arms. Is that for scientific research and the weather detection. And by the way, when these 2 nanosatellites are sending, we collect a lot of picture of atmospheric issues. So we can right now just have a lot of picture, and we can detect how if the weather are raining or not. So 3 days ago we have some results about some atmospheric weather. So we can now have some images for to have some results about how they will be raining or not. Or also the rise of the commercial satellite industry are developing, because like I see later, the development of power communication satellites way for the emergence of commercial satellite, and also the cost and the technology using in every satellite. Also the connectivity. When we send a lot of nanosatellites, we make like we see a constellation, so we can connect it all this nanosatellite with others. So we have a lot of data. We can send it. Also, what we call this kind of nanosatellite is a future of space exploration. Maybe some astrophysicists, physician or scientists say this kind of nanosatellite can give us a lot of problem, like they make what we call light pollution, or we can't not observe some stars, or maybe some comets or something like this. But what we know, the volume or the size of this nanosatellite is so small. So when we send it this kind of nanosatellite, we can just little downside the size of satellite, and also we remove what we call some garbage on satellite or something. They give us a lot of problem. Like you say, this is some size or maybe some kind of there is a lot of unity. They have one unity. It's their volume. It's 1 meter cube, uh, 10 centimeter cube, and the and they are less than 10 kilogram. This kind of satellite, we use it to reduce the cost and the faster using also for faster deployment and increase flexibility and scalability. And also we use it for communication and legacy Earth observation. So the challenge and limitation of non-satellite, it's about limited power. Non-satellite have a limited power capacity, which restrict their lifespan and the complexity of tasks they can perform. Also, the data transmission constraint, like you know, the data transmission is not high. Also, the environment challenge. You know, when we send some small pieces of satellite in space, we have a lot of like radiation and space debris. The future of this non-satellite technology hold the great promises with the continued advancement in power sources. So we think this kind of non-satellite can help us and they can give us a lot of things to have good communication and navigation. In KNES, we work in research development and the satellite mission and international collaboration and innovation group. So we try to work in with a lot of students in Europe, in Africa, for having a lot of information and experience in satellite and aerospace technology. We make some workshops to give us to all students in engineering school to have to build our nanosatellite, or maybe to build their CubeSat. This nanosatellite application uses, like I see, all this thing. This is what we do in KNES. We do the collaboration, and we work on also in to build and to have some satellite in Earth observation, also in astronomy, space weather, and atmospheric research. By the way, this center is built 1,000 of satellite and non-satellite. Morocco will build two satellites. It's the first one is Mohammed 61 and 62 is big satellite for space weather and atmospheric research, also for Earth observation. And there is some collaboration with the Camden Observatory, so we can also with the Camden Observatory for have for give some experiences and share with the students of astrophysics masters to how to build CubeSat and some satellite for pollution, light pollution detection. So we do a lot of things in KNES. Like I see, we have two kind of collaboration with Camden Observatory and Observatory of Paris in the European observation. So we try to make some student exchange program. French and the Moroccan University offer exchange program, allowing students to experience research different environments. Also, the faculty collaboration, we can some research from both countries collaborate or join project and participate in each other academic conference. Also, we do some mentorship.
Mourad,
yes.
Just to tell you that you have 4 minutes to complete, please.
Okay. Okay. Thank you. I will go so quickly. So we do a funding and the research sharing, making some internship and giving some opportunities to students, and also I work with GO. It's called Astrolab. Astrolab is like an NGO who popularizing science, especially astronomy and aerospace technology. We think we can give a lot of things to kids and share with him a lot of experiences and teach him and give him some mentorship. So we try to make some experiments and activity in aerodynamics and the gravity and space, rocket propulsion, and astronaut training. So we build some rockets challenge, and we design a lot of sheets. I can share it with you after this discussion. And we also working in the drone piloting competitions. So we try to make some training like this for a fundamental of flight, obstacle courses, and competitive flight. And we working also to have some satellite design projects in our simulator. Also, we give him a lot of exploring the solar system with a planetarium, virtual exploration, telescope observation, and solar system models. Also, we try to have some robotics programming, autonomous system, and data analysis, the visualization space. So we try to inspire our children. So for that, we built the first festival of scientific heritage in our cities. It's called FAIRS. So we're working with a lot of students. We have 3,000 students who have the opportunity to visit our in this festival. We make a lot of workshops in solar energy, wind energy, hydropower, and astronomy, and medicine, and a lot of things have a relationship with astronomy. So for that, we work also in artificial intelligence, machine learning, robotics, and natural language processing, and we build our the first planetarium. It's look like a ball, what we can see in this wonderful picture. So we build our first planetarium. It's planetarium made by our arms, and try to have some geometric issue, and building with a lot of love and passions. And also in the final we made a training for 30 students aged 50 to 18 to explore the vast world of space, covering everything from rockets to robotic and astrobiology. So we do a lot of experience with him, and we training him for 50 days. So they are very, very happy to have the experience to be in this training. And this training, it's called MISI, Moroccan Initiative Space Industry, and we try to share with the students and kids all what we have. So I hope it's passed quickly, and thank you for your time. And if you have any question or anything, you can just say yes, I'm here. Thank you.
Thank you so much.